So, assuming you have gone to lucid.app online and have made your own account and have gotten used to building things, and let's say you have built out your logic for your game here, where you start the game here, then you go into this decision tree. You could exit the game, or you could start. You could choose A or B. If you choose A, you could go to another decision and choose A or B. And then eventually, no matter which route you take, you will end up at the starting decision here. And that will give you an opportunity to continually change all these variables you have over and over again until you see all these stats change as you play the game. And so as these stats change as you play the game, you may have your hunger level go all the way up, and then you could die from hunger, or you could get your thirst level too high and die from thirst. We haven't decided on the rules of the game and how you win or lose, but this is the basic layout that we've built. So using this layout, let's go ahead and program our game. This is not always the way you will program things. This is just a helpful way to lay out the logic so that you can visualize what it is you're coding. These are the paths you can take in the code. So with that said, let's open up a new Visual Studio and make a new file. I called mine survivalgame.py. Let's get started. Let's print to the screen the ASCII art that was in the text tutorial. So I'm actually going to comment out all of this by hitting Control K, Control C. If you highlight everything and hit Control K, then Control C, it will comment everything out. So just line by line, we can just print this. Let's make a bunch of print lines here. And let's print this. And I will fast forward the video so you don't have to watch me copy and paste. Okay, I copied and pasted all that to the print statements. Maybe there's some touch-ups we could make here to align things to make it look the way we want. This is not a huge part of the importance of the game, but it's good to know how to do some ASCII art if you like that. You can go ahead and look up other kinds of ASCII art online, just ASCII art, and that will give you plenty of options to choose from if you just want to try to find a palm tree or an island of some kind. And let's also print out this statement here. And so we can have this not as a print statement, but it will print it if we also do the input. So let's add input here, and we can assign this input to a variable. Maybe we call it play game. And let's just see if we can actually print out the value of play game to make sure we get what we think we have got inside play game. Let's see if that works. Let's take out the commented code we don't need anymore and see if the first part of the game actually works when we run it. So click play, and look at that. We have our first lines of code of our game, and it's working. So let's move on. Sorry if the text is a bit small, I can zoom in here for you. So maybe we should compare while we write the code, get our logic here. So we know it's working. Now we want to make a decision tree, so it's an if statement. Depending on what the input is of this first question, start or don't start, we will either go here or we'll go here. So how do we exit the game? Well, actually, this whole thing, this entire process here is one gigantic loop. So actually, if we don't enter this loop, the game will exit. So that's step one. Let's try to just make a loop so that we can exit it, so we can at least cover this part. And this is the tricky thing about programming is if you're not experienced, it's hard to know that. So just as well, we could make an if statement, and then we'd later realize we'd have to change that if statement into a loop to get this whole loopy process going on here. So let's do that. Instead of printing play game, we'll say while play game is equal to y, enter the loop. And so this next decision actually should be, I think it should be an if statement. So let's try an if statement. If, what are we deciding? Well, looks like if we choose A or if we choose B, then something happens. So we have to actually get input again before we go into this decision. So right here, actually, we could have put, take input just before the decision so that we can decide based on the input what to do. So there's more detail we could have added throughout this whole thing. This is a good overview of the whole main idea. Input. Let's ask the user, do you want to pick up a rock A or shake the tree B? Going over here, we can add in the response to the left and we can call it, this is maybe a bad name because it's not very specific, but we can call it decision 1. If decision 1 is equal to, let's say, A, then what do? We will go pick up a rock. Maybe we just say, you have picked up a rock. Exciting. So we've added actually a fair amount of code here already, and we haven't even tested if any of this works yet. So why don't we do that to make sure all of this works the way we expect before we keep writing more code. So let's do that. Let's run and go down here. Welcome to Virtual Island Survival. Get started. Yes. Do you want to pick up rock A or shake the tree B? Let's shake the tree B. Oh no. A? Oh. So it looks like we got stuck in the loop. If we choose, what happens is if we choose anything other than A, we go out of the if statement and then we go back up to the while loop and then we get the same question again. So it's like this loop is working, but it goes back to this same question immediately without doing any of this other logic. So we have to put all this other logic in here before we continue to go back to the same question. But we do eventually want to go back to that question, choosing A or B, after doing all the rest of this stuff. So we'll leave that as it is. So let's continue. So after shaking the tree, which was B, we skip this if statement and we go down here and we can add in congrats, a coconut fell on the ground. So we can say that. Or we can say you shook the tree and a coconut fell on the ground. Congrats. What else? Then we decide to open coconut with rock, or we can save the coconut for later. So that's another decision we have to ask and get the input before we branch off to these other results here. So let's ask, let's say input, and, we can just ask
open coconut with rock A or save coconut for later B.
maybe call this decision 2. And if decision2 is equal to, let's say, A, if it's A, then we can go show this message inside the if statement. And after that, we can do this message stat thing here. So let's show the message if it's B, I mean A, colon, and then we can just say print. Oh yeah, here's where we start working with variables too. So you have to recognize you have to start changing these variables in the same if statement and show the message. So in this if statement, in the case that it's A, this A option, all of this stuff happens in that case. So everything inside here in this if statement will have to be changing the variables here. I'll just put a comment so we don't forget to say take a coconut from the tree. You know, there's just a number that we're going to use to keep track of how many coconuts are in the tree, or the trees. Then you can set thirst to 0 because you drank whatever was in the coconut, and you can get a little more hungry because you're not eating very many calories. Maybe coconuts have a lot of calories, I don't know. I'm not a nutritionist. Increase hunger, thirst equals 0. I'm just commenting these because we don't have the variables yet. We shouldn't be changing variables that don't yet exist. And these are variables that are going to exist in the whole program, so we would want to define them maybe up at the top here or just before the while loop. So at least let's print this and then we can test to make sure things are still working as we expect. So there's all these other decisions we haven't gone into. I'm just going down one route so we can start building something and we can continue adding on from there.
Maybe decrease that size. I can say, you have used energy to shake the tree. And open a coconut. Maybe we do another line after that. And say, you are slightly more hungry. But you are not thirsty anymore. Or you've satisfied your thirst, however you want to say it.
So let's see if this all still kind of works the way we were hoping. Let's stop the program. Wait, we're in an infinite loop. We can't get out of this. How do we get out of this? I hit Control C and that's what got us out. So if you're stuck in a loop in your program, you haven't programmed your way out, just hit Control C. There's probably another way to exit it. So let's hit play again. Let's hit no just to make sure it exits out properly. And it does. So let's hit play again. Enter the loop. Do you want to pick up rock? Pick up a rock? Yeah, let's pick up a rock. So do we want to open up a coconut with a rock? Yeah. Oh no, we didn't put the colon here. Just noticed that. And do you want to pick up a rock or shake the tree? So it looks like what's happening is when we entered A here, we were right here. Then what happened is we exited the loop, went back around, and landed on the same question, which was the first one, which is do you want to pick up a rock or shake the tree? That's our first question that's in the loop. And so we can say, maybe let's try the other one. Let's say B, shake the tree. And open a coconut with a rock or save coconut for later. Oh no. Essentially what we've built is an extra arrow that leads to these other questions. That's not what we want. So to fix that, you have to put else. Instead of having all this here right after the A decision, the first A decision. Maybe we say else we do all the rest of this stuff here. I hit tab. Then we can say, okay, you shook the tree or you picked up the rock. We can either enter into this code, this if statement, or we can enter in the else. Just kind of pay attention to how your flow, the flow of logic is working, and you can prevent yourself from running code you don't want to run. So let's test it again. And also let's add this colon that we forgot, or that I forgot. As you start writing more code, it's going to look like, wow, this is kind of annoying to look at, because you may want to break this code apart and organize it in a way that makes it look better. And there's a way to do that with functions. And I will show you just a minute after we test this out how you can break that apart into multiple functions. Let's hit play. Actually, I'm going to hit Control C, type clear to clear everything out. Let's take this up here and let's play our game. Why? Let's pick up a rock. You've picked up a rock. Awesome. So now we don't go into the other code. Everything is looping back to the same question now because we haven't built out more branches for that part of the code. So essentially what we've done is we've picked up the rock. We don't have this decision, so it's basically skipped over that, looped all the way back around, skipped this, we don't have that yet, went back to this decision, and we're asking A or B. So the only code we really have to test is in this B now, so let's make sure we say B is going to shake the tree. The coconut fell on the ground. Congrats. Now, open the coconut with the rock. It's the second decision. We shook the tree. Now we open up the coconut with the rock or save it for later. I want to open it up with a rock. So let's say A. And you have used energy to shake the tree and open up a coconut. You're slightly more hungry. So you're not thirsty anymore though. Now we've gone back to the same question, the original one. Pick up a rock or shake a tree. So that's all working. Let's also test the, so we've tested B and then A. So we can test B and then B. So let's do that. Get started. So B and save coconut for later, B. Do you want to pick up a rock or shake a tree? So yes, we've looped back to the same question again. Everything seems fine. Cool. So I just realized I have this cool pencil thing I can use here. So let me show you what we have so far. So we have done this. We've
made the fancy tree here. And, the islands with the water, whatever. Whatever, how you want to see a tree, I don't know. That's obviously what we have here. So
then we came down here. We asked a question with the input. So now we can start the game using that information in the string. If we hit N, the game exits and we can't play anything anymore. If we hit yes or Y, then, or actually if it's anything other than Y, it doesn't have to be N. We said if it's not Y, exit the game. So anyways, then we go down here and the next question we ask here is the first question at the top, which is, do you want to pick up a rock or shake the tree? We've covered this and we can pick up the rock, but we don't have this decision yet. We have stopped here. We can shake the tree. We can get a result here. We can go open the coconut with the rock. We've gotten all the way here. We've even shown this message and we've gone all the way back here. We've skipped over this and gone back to this decision tree. We've even gone down here, gone through these ones. We've skipped over this and back to the decision tree here. And those are all the paths we've taken. So we've covered this, and we probably want to cover this one next or the rest of these. See what happens when we try to cover this one. I do know that these require variables, so maybe we should set up all the variables to start using those. So the hunger level, what should the hunger level start out as? Let's say if you're not hungry, it's 0, and the hunger level just increases maybe till it gets to 5 or 10, and then maybe the player dies on the island or something. So let's go up here and say hunger level equals 0. Then we can say thirst level is 0 also. And rocks available. Let's start out with, I think we said 5 rocks. And coconuts saved. These are coconuts that you haven't eaten yet, that are not on the tree. So let's start with 0. You haven't saved any coconuts off the tree yet. Goats. Let's just set that to 1. Saved meat, 0. We don't have any meat saved. Survival time. We have not survived any days. Maybe just days survived, maybe, would be better. More exact to have a variable that is a unit of days. Also, I noticed we don't have any way to keep track of how many coconuts are in the tree. We just said coconuts saved. Maybe we should say, yeah, it does say it down here. I just didn't put it in. Coconuts in trees equals, let's say there's 3 trees and 3 coconuts in each tree. Or actually we'll just say 10. We'll just say 10 coconuts total in all the trees. Maybe 3 in one, 3 in one, 4 in the other. Doesn't matter. There's 10 coconuts in all the trees we have. So this, or maybe there's one tree with 10 coconuts, like the pretty picture. But it looks like there's no person or goat or coconuts, so maybe they all fell in the water, or they haven't arrived yet. I don't know. You can make a goat here if you want, or a coconut if you're really good at ASCII art. So now that we have these variables anyways, we can, all these variables are just integers, so we can add or subtract, values to these integers as we play the game. So like for here, for instance, we can say, take a coconut from the tree. So like, we'll just say, okay, coconuts in the trees. We're going to say, well, from 10 it goes to 9. But what if it's 9, it goes to 8? So we just want to take one from what exists at any point in time. So we say, we can copy this variable and say, this variable is equal to what it was before minus 1. Another way of doing this is saying minus equals, that's the same thing as this. So it depends on what you like. This is the same thing. If it's easier for you to make sense of this, go for it. It's the same thing. So let's add in increasing the hunger for this specific instance here for decision 2 when it's A, decision 2 here. maybe we could label these or have like better names for these decisions here, but just for the sake of learning the logic, learning how to program, um, we might not need to worry about what these decisions are called or have a special system for naming the decisions. So as long as you have a good idea of how all this logic is working together, that's what matters. So anyways, let's increase the hunger. So hunger equals hunger plus 1. We called it though, call it hunger level. So don't forget to name it the same thing, otherwise it doesn't exist. Like if we just said hunger equals hunger plus 1, we could try to run that, but it would be like, wait a minute, what was hunger to begin with? It wouldn't know what to do here. Let me show you if you don't believe me. Let's go, what was it? Decision B, then decision A. So let's play. Oh no, we can't even run it because it doesn't know what hunger is. Name error, hunger is not defined. So if you didn't believe me, you believe me now. So let's make sure we call it, oops, let's make sure we call it what we named it up here. We can refer to it because it's been set to 0. Now it knows, okay, this thing that's 0, let's add 1 to it when we run, this second decision and it happens to be A. And let's set thirst. Let's say over time the thirst level could increase at any point in time. So we're setting it to 0 here, just in case, it's 1 or 2 or 3. These comments are kind of useless now because the code is actually pretty self-explanatory if you name your variables things that make sense. So you should be able to read through this code and have a good idea of what it's doing. It kind of does look a little jumbled, so like I said before, we can split this into functions just for the sake of organizing it, and that's okay. So maybe one of the functions we have is called shake tree. And then we could actually say, hey, let's put all of this code into this function. And then make sure it's indented properly the same way it was before, to the same relativistic level. So when we enter in the function, we immediately say, you shook the tree. Then we go down this other path. Maybe we could split this into another function too, so that this function calls another one that we call open coconut with rock. We can have like an open coconut with rock function. This is just organizing the code so that you can actually delete all this and instead just say shake tree. That's kind of fun. That's all you have to put there. Look at how easy that is to read. So what if you have to open the coconut with a rock? Well, you can say define open coconut. I mean, there's only like one way in the game we have to open a coconut, and that's with a rock. So maybe we don't have to say with a rock in the function so that it's like a little bit shorter, easier to read. So let's say this is everything that happens when you open a coconut with a rock. You can copy all that, put it in here, and just say open coconut right here. There you go. So now you've split up this code into chunks, which makes it readable here makes it more readable here, and let's unindent these. Shift tab unindents a selection. So let's see if it still runs. So if this code all still runs and it's cleaner looking, we can keep building out more, and that is awesome. Hit play. Yeah, let's play the game. Do you want to pick up a rock? Yeah, I want to pick up a rock. Do you want to pick up a rock? Well, looks like I can't do anything if I pick up a rock yet because we didn't program that yet. So let's pick up, shake a tree. Oh no. Shake tree is not defined. Maybe we need to define these above. In some programming languages, you can define them below. It will compile and understand everything. But in Python, you have to define them before you use them. So let's define them up here. Actually, let's define them up just after the variables. Its own little section of definitions. These functions have their own section. There we go. So we go down here, and then we just call the function shakeTree. Let's see if that works. Play. Hey. So what if we do want to play? Pick up a rock, shake the tree. Let's shake the tree. Open coconut with rock. Looks like it's working. Yeah, let's open a coconut with a rock. Oh no. Okay, so why are we seeing this error? Why are we saying coconuts and trees cannot access local variable? Well, okay, so in Python, the thing about these variables is it assumes that you have to make all these variables inside the function or they have to be passed in to the function. Unless you use a specific keyword that says, I want to access this variable from outside, like up here, these are global variables. You have to tell it, okay, by the way, Python, there's a global variable in here. So this coconut trees variable is global. You have to tell it that before you start using it down here. And if we do that, we run this Python program again, hit yes, shake the tree, open coconut with rock, A. Oh no. This hunger level variable is doing the same thing. So we have to do the same thing. We have to say, okay, global hunger level, and there's another one, thirst level. Oops. Thirst level. There we go. Now, if we run this again, Python, shake the tree, open coconut with rock, and we fixed the error. You have energy to shake the tree. You've used energy to shake the tree. You're slightly more hungry. You're not thirsty anymore. So you drank whatever was in the coconut. Now we're back to pick up a rock or shake the tree. So let's shake the tree, save coconut for later, or pick up a rock. You picked up a rock. Okay, so now we probably want to see what's going on here. So let's add in another chunk of code that will give us the opportunity to see what's down here. And that chunk of code, just make another variable. We can just make another function. Say define show stats. And this will be the chunk of code we can refer to. This function will allow us to see the stats. And we're just going to print stats. We can probably just do this. And then at the end, we probably want to do like, something like that. And then in between, we can show the actual stats. We're going to print out, let's say we want to print out just the variables that we're manipulating so far, which are these up here, these coconut and hunger and thirst level. So let's copy that, put it in here. Coconuts and trees. Just make it look fancy, then actually put the real variable in there. And then hunger level and thirst level. Actually show that we want to call it hunger level and thirst level. So let's see what happens when we actually use, we've defined it here. So now let's go down and actually use it. Let's assume we want to use it, we want to see the stats every time before we pick up a rock or shake the tree. So let's put it right here. Show stats every time. We should be able to show the stats there. So as you noticed before, we have to use these global, we have to put these here in the function for it to know, oh, we're using these from outside the definition. So set them in right there too. And this function should work. So let's go down here and remember to test as often as you can. Hit play. Let's, I want to see what's going on here. There we go. I want to see the beautiful tree. Now we can hit the yes, hit Y, then there we go. We have stats. How many coconuts are in the trees? 10. We're not hungry, we're not thirsty yet, so it's like we just got to the island and we want to know, should we actually like pick up a rock? Well, we don't even have stats on rocks, so why should we care about rocks? Let's just shake the tree. I want to get coconuts. B. You shook the tree. A coconut fell on the ground, congrats. Okay. Let's save the coconut for later. See what happens. Oh no. Coconuts in trees, 10. We didn't actually change the number of coconuts in the trees. What's going on? So we shook the tree. We saved the coconut for later. Now, why is the coconuts and trees not doing what we want it to do? This is not actually a bug in the code. We just didn't code it right. We didn't add the logic the way the logic is supposed to be added. So, what did we not do? We changed the variable. In the case we want to say the second decision is A, we changed the values here. This is inside the second decision when we say, actually use the coconut and drink it. However, we should actually be changing, whether the coconut is in the tree or not after we shake the tree. So if we shake the tree, the coconut falls. The coconut doesn't fall when we open the coconut. So let's take this coconuts and trees here. Let's put it up here and shake the tree. And take this and put it up here. So the coconuts and trees should actually, we should subtract that value when we shake the tree. So a programming language is already defined to work. You kind of have to be humble as a programmer and think, automatically you think, is it me? Yeah, it's probably you. All programmers are humans. All humans make mistakes. The computer, very rarely are you ever going to run into a very specific circumstance where an actual programming language is the problem. Most of the time, people just don't fully understand how to use the programming language, especially when we're learning. It's just going to take time. So keep that in mind. You have to be patient. Obviously, let's go test what we've changed. So pick up a rock, shake the tree. So let's shake the tree and save the coconut for later. So there's one less coconut in the tree, but maybe we should actually get hungry after trying to shake the tree. And maybe we should also get thirsty after shaking the tree and not drinking the coconut. So let's revise this. Let's say, okay, let's shake the tree. You know, and if we open the coconut, thirst level goes to 0 anyways. But if we shake the tree, we're exerting energy. So before we even open the coconut up here, we should say, you know what, let's make our hunger level and our thirst level change. And the hunger level should increase. And let's actually also increase the thirst level the same way. So let's copy that. Copy the thirst level into here. So we're changing the thirst level in the same way. Now that we have that, let's test it out again. You see all the details that are going into this that we didn't put into here. There's a lot more to, actually trying to program something is different than modeling every detail. If you try to model every detail, it's usually not going to work. You're going to run into different issues. You can't foresee every single detail that's involved in coding something. That's why coding, often you have to test as often as you can. So let's do that. Remember that if you do A, it has to be capital A, and anything else will be the same as B. B, lowercase b, doesn't matter, because we said else here. Only if it's A do we do this, otherwise we're shaking the tree. So, I mean, we can do capital B, lowercase b, doesn't matter, we're shaking the tree. You shook the tree, a coconut fell. Congrats. Open a coconut with a rock. Well, or save the coconut for later. Let's test the circumstance where we do not do A. So let's just see what happens if we don't open the coconut. We just save it for later. So that's B. And coconuts in trees, 8. Oh no. It's not good. Wait, that's good. We didn't even restart the program. Huh, my bad. Okay, so, Control C, clear. Let's actually run the changes we made. So, I actually had to stop the program so we can actually see the changes here. So, yeah, let's play the game, check the tree, save coconut for later. Now we have the changes we expect. So we got hungry, we got thirsty, but we have one less coconut in the tree. Maybe we should show that we saved one of the coconuts. So right here where we have, coconut saved 0, let's increase that to 1 and then actually show that in the stats. So if we shake the tree and then we choose a decision that's not B, so else we're gonna say coconut saved. I'm just gonna do plus equals 1, which is the same thing as saying coconut saved equals coconut saved plus 1. Same thing as these up here. I'm actually just gonna just to make these shorter, just so you can see that there's this option also. I'm just gonna do plus equals 1 for these. Also, it's the same thing. And this one is minus equals 1. There you go. It's a little bit shorter, and if you like that, you can keep that. So we have changed coconut saved to 1 more if we did not open the coconut. And
we can show saved coconuts to saved, coconuts saved.
And Gotta go back and test it. I might have made a mistake. You never know. Say B and save coconut for later. Oh no, I made a mistake. Look at that. I completely forgot to coconut saved, add that to global here. So gotta remember to do that if you're gonna, work with the global stuff in functions. Um, when we get into working with objects and classes in the next, in the next lessons after this, you're gonna realize this is maybe not the best thing to be using all the time. You're not gonna need to do this very often anyways.
Going back down. Let's test it again. Yes. Shake the tree, save it for later.
Oh no. Coconut's saved again. And obviously I forgot to add it up there too. Let's add it up there. This is why you test.
You want to pick up a rock? No. Open a coconut now. Save for later, yes.
There we go. We've saved a coconut from the tree. We're hungry and thirsty. But at least we have a coconut saved to open it whenever we want to satisfy our thirst. But the hunger level might go up still, so we're starting to get into some strategy here, and you can eventually, you could modify this game to be whatever you want, but I'm gonna stick to adding the rest of this logic over here, and we'll see what this ends up being. So let's do that. In fact, I'm just going to add the rest of the stats messages. So I'm just going to copy all this.
Paste it here. Hunger level, we took care of that. Fish level. Rocks available. Coconuts saved. Took care of that. Coconuts and trees, we have that. Goats save meat. Okay, these ones we want to make level. We're not going to set the values anymore. Get rid of those values. Just want to make sure we have all the variables showing in the stats. So we want to make sure we're, telling this function we're global. So now let's add the rest of these after coconut saved. So I think there's 4 more. Rocks. Goats. Saved meat. They survive.
So, oh yeah, we gotta remember to increment the days each time. Maybe each time we look at this stats page, we should increment the number of days you've survived. So let's do that.
Saved meat. Saved meat. Goats. Rocks available. There we go.
Should be able to see all these stats every time now. And is there anything else we're not taking into account? Maybe there's something else we're not taking into account here, but we'll figure it out later if we need to. Just do what you can. So throw a rock at the goat or throw a rock at a coconut in the tree. So if you throw a rock at the coconut in the tree, we might, according to the logic in the game, you're gonna lose the rock, it's gonna fall in the water. So you can imagine if you're on this island here. Here's a person. And you throw the coconut, hits the tree, but then the rock bounces in the water. Or maybe you're on the other side. Rock bounces in the water. And then the coconut falls. But maybe you didn't exert energy, so you're less hungry. So that's a strategic advantage to throwing the rock at the coconut, but then you have one less rock. So let's go up and let's define a function where after shaking the tree, define a function where you actually pick up, the rock. All the things that could happen after you pick up the rock, we're going to put in here. So let's define a function. It says you picked up the rock. Pick up rock. We haven't defined it yet, but we're putting it here so that, we can actually use it once it's defined. So shake tree. Let's put everything. I want to put pick up rock, define it here. Doesn't matter. Oops. Pick up rock. There we go. Everything should be running the same. Pick up the rock. And looks like rocks available is the same, so at least we can change, let's say rocks available minus equals 1. Make sure that changes when we run that. So look at this. If we hit A, oh no. Look at that. Glad I tested that. We want to say global rocks available and actually have the ability to use that. So get started. A. Look at that. We got a rock. We picked it up. And we use it. Now, if we use a rock to, throw at a coconut or throw at a goat, let's just say it gets stuck in the goat and you can't find the rock. That's it's probably not a realistic situation, but just for the sake of having limited resources, let's just say every time you pick up a rock, it's gone after you use it. Yeah, I don't know. You can make up whatever logic you want in the game, really. It's your game. So don't feel obligated to follow what I'm doing. You can make it as big and complicated as you like. The next thing we want to do is we want to say, hey, what's the decision here? Do we want to A, throw the rock at the goat, or B, throw the rock at the coconut? So just like we have done up here, you can make a decision, 3 or something. In fact, this is local, so this can be like a decision level 2. Like it can be a layer 2 decision, just like this is a layer 2 decision. That could be an okay thing to do. Like you can say decision, call it decision 2 down here. Also, we can't, this is not a global variable, so we're not going to get mixed up here. That's okay. So we can say decision 2 equals input
Oh, rocket goat. Or the rocket coconut.
So what do we do if it is A? Well, we should probably make a function for this stuff here because it looks like there's more involved here. You may not need a function for this. It's just a message and then we go back around. So let's at least, say if we go decision A, all of this is in its own function. So that would be throw rocket goat. Now, if you're excited, about all this stuff, you think this game is super cool, then I think you're going to be excited when we get into 2D gaming. There's going to be a lot more involved there, more physics, more, really interesting things you can do in 2D or even 3D gaming. So just realize, once you master these concepts, a lot of this, you're going to have to keep a lot of these skills and use these same skills in 2D, 3D programming, machine learning, anything you want to do is, pretty much any other form of software engineering is usually going to require you to, use these skills that you're learning right now. So don't get down on yourself if you think it's a little bit boring either. Like this is still, uh, impressive if you're learning to program and building a game. Learning to program at the same time can be a bit difficult. So don't feel frustrated at all. Keep pushing forward. If you need to Google some terms that you're not familiar with, feel free to do research on your own for anything that might be confusing at all. So let's continue. If we throw the rock at the goat, well, the decision actually, we need to actually, use this function. We need to use it after the decision has been made. So if decision 2 is equal to A, then we can throw the rock at the goat. Else, what do we do otherwise? We probably should do, this stuff right here. I went overboard on that. I mean, throw a rock at the coconut. So we could make a function for that, but I'm just gonna like, actually, you know what? Let's make a function for that one too. We're gonna define throw rock at goat and throw rock at coconut. Why not? Throw rock, else throw rock at coconut, just so it reads like English. So it's very clear what is happening in your code. Throw rock at coconut. Wait, how do you spell that? Okay, so coconut. Here we go. So what do we do if we throw the rock at the goat? Like what? How do you throw a rock at a goat? In code. Decision. Well, it looks like you have to set the goat alive variable to false. We don't even have a goat alive variable, but we do have a number of goats. So like we could say goats minus equals 1. But what if, oh no, what if we don't have goats left? What if we try to what if we loop through this and we run out of goats or we run out of rocks? You see, we have to start thinking about these things too. But for now, actually, let's keep it simple. Let's just say you can have negative goats till we go change that. So here we go. Throw rock a goat. Goats. Was it capital G? No, it's lowercase. Goats minus equals 1. So there's one less goat if we throw the rock at the goat. But then we have to keep going into the code. We have to keep going. Okay, right after this line, it's going to skip all this because it doesn't exist. It's going to throw the rock at the goat. Like, you're going to be bouncing around a lot looking at these functions, but just remember, it is breaking apart the problem for you. It will keep it simpler if you, learn to read your own code and make good names. It's gonna look like English. It's gonna start looking like, it's a language. You have to learn it, and you have to speak it and type it well. You have to be able to type it well and create good code in order for it to be understandable and clear. Just like when you speak clear English, people understand you well. If you write good code, the computer understands you and people can also understand your code too. So it's good to understand your own code. So keep things organized, break things apart into functions. Anyways, let's go to this decision. Should we eat the meat or save the meat? Let's say the goat is, let's at least print a message. Let's say print the goat has been hit. And then we can say, let's take some input. Actually, let's save a variable.
Decision 3, a level 3 decision, let's say. And let's say print out input. Meet option A. Or save. And once we have that decision, we can decide whether the hunger level goes to 0 if decision 3 is equal to A. Let's say we eat the meat. Let's just say we do that. What happens if we
select A, choosing to eat the meat? Well, hunger level equals 0. We can say print, hey, you're not hungry anymore. Let's just make it happy. So, what if you do something other than A, or else? You could say else, else if decision equals B, and then you could say have a third case that, like, if you say C, you could say, like, you could do this. You could, if you want to be fancy, you can go through this whole thing and say, it has to be A or B, and if it's B, you could say saved meat plus equals 1, and you can say else, else, please, you could print please enter, either A or B. Because if you didn't enter A or B, you can't, there's no third option. You have to go back up and enter A or B again. You could make this a loop. But, that's overcomplicating it, honestly. Doesn't need to be. This is just for the sake of, expanding your knowledge, making something fun. So let's keep it simple. Let's just say else. Could be pretty fancy. You could make it fancy. And in fact, if you feel like this is boring, I recommend you go make it fancy and see, see what you can build. You have to push your limits to really learn the most. I'm just going to do else for now. So let's say, okay, saved meat. We add that, and then we can say print. Maybe to save the meat you want to use some salt or something, but maybe that's for a more complicated game where you have salt and you have 20 goats and you have 50 rocks and you can make it. Maybe you go to another island and there's more, like the second level, you can make more goats and more resources to strategize with. So
for now, I'm just gonna say you have saved your meat. And let's call that good.
And then maybe after 3 cycles, if you want to continually be fancy, you don't want to save it for too long. Maybe you want to say, oh, the meat went bad after 3 cycles. You can do that. You'd have to put some more code in there to specify that logic. Anyways, I have probably written way too much code here. Because, you know what? If I run this, there's probably going to be an error. But, I've seen a pattern in my errors. And I keep forgetting to add these global things. So I bet you I need to just do that. And it will run okay. So global goats.
Level. Hunger level. Saved meat.
Those are the three, variables that are affected in this function if we throw the rock at the goat. Now, if we throw the rock at the coconut down here, we can make this, and, let's just.
That's our code. Say, we can add more here later.
So let's test to see what we have so far. Let's test to see if it works. Wait, before we test it, let's look at the code one more time. Oh no, I can see here, rocks available. Oh wait, yeah, we're good. This is the only one we really change in here, so no more globals needed there. Uh, yeah, it's all looking okay. Let's test it. Let's test it. Oh no, invalid syntax. Oh, so this, yeah, this is obvious. Else's do not have any, expressions. So this expression here in the else, I mean, nothing should be after else except for a colon. So, boom, that was the issue, I think. Let's test this again. Okay, so, yeah, looks like it's running now. The change was successfully made to allow this to run. So let's get started. Do you want to pick up? Let's just pick up the rock. You picked up the rock. Okay, should we throw it at the goat? Yeah, let's try that. The goat has been hit. Should we eat the meat? What if we do? Um, looks like we don't have meat saved. That's fine. Hunger level is 0, but where does our hunger level really ever increase? Maybe we should be increasing our hunger level in these other steps. So something to think about. Yeah, we increase the hunger level when we open a coconut. Maybe we should increase the hunger level when we throw the rock at the goat. Like right here. And make sure to report hunger level. So even if you save the meat, the hunger level goes up still. But the hunger level is set back to 0 regardless of what it ends up as here. So that's fun. Pick up the rock. Yeah, let's pick up the rock. Let's throw the rock at the coconut. You threw the rock at the coconut. Nothing else happened though. So let's have something else happen. Let's keep building it. I think we're doing good. Maybe we could have tested the other, option where we actually save the meat. I suspect that's going to be fine, so... Oh yeah, we did have a logic here, so we want to make sure we make the rock count go down. Let's do that. Rocks available. Oh yeah, here's the other thing you have to think about. Can we throw a rock at the coconut if there's no more rocks available? Well, we have to pick up the rock here. So, if it didn't let us pick up a rock, the only alternative would be to shake the tree. And if we have nothing else to shake the tree with, like there's no coconuts, then our only option would be, maybe go eat what we have to live off of, see how long we live. We'll probably work on that later. But, stuff to think about here. So let's make the rock count go down. If we pick up the rock, the rocks available. Okay, so a lot of this stuff, maybe we don't have to overcomplicate this, but yeah, rocks available minus equals 1. And coconuts and trees minus equals 1.
And saved coconuts. Minus equals 1. Oh no. Hold on. We cheated about the rocket coconut. Yeah, it's plus equals 1. Don't want to make that mistake. We have more coconuts now. Don't want to die from thirst. Okay.
You have one more coconut and one less rock. So let's say that.
We have one more coconut. Oh, that's not. There we go.
Then by default, this will exit out of the definition and go down here. It'll hit this. It'll go back up here and go back to this decision. So let's play the game. Make sure everything makes sense. Looks like we've hit pretty much every decision that we've designed. Now it's just a matter of us refining the game so that it actually makes sense if, let's say there's negative numbers involved. You probably don't want that to happen. You want to start blocking the ability to go through to certain decisions. If you don't have rocks or if you don't have, coconuts. So just it's a matter of testing and modifying. So by now, hopefully you understand how to start modifying this on your own. Start growing the game. Have some fun with it. Let's test it out. Let's run this. Let's get started. Okay, coconuts and trees. Do you want to pick up the rock? Yeah, I'm gonna pick up a rock. Throw a rock at goat. Throw the rock at the goat. The goat has been hit. Let's save the meat. And save the meat. Oh no, we forgot to worry about the days survived. So, you know what? I was hoping to play this game, go through a couple days, but I can't be happy knowing that time isn't even passing. So, I could be on this island forever. Days survived plus equals 1. In fact, let's do that after we say days survived is 0, because like by default it's 0, then we show it's 0. Right after that, yeah, let's just do it at the end, so that the next time we see it, it will be one more day. So clear, hit play, let's play. There we go. Fresh. Yeah, let's pick up the rock. Throw it at the goat. Okay, eat meat or save meat? Let's save the meat. When do we ever get to use our saved meat, though? Maybe that's for if we run out of everything else. But then it could go bad, so, it's up to you to design the game how you want. Let's throw it at a coconut. Oh no, we didn't even add the globals here. There we go. So what case was that? Throwing a rock at a coconut. Let's go try to throw a rock at a coconut again. Do you want to pick up? Yeah, let's pick up a rock. Let's throw it at the coconut. Oh no, saved coconuts is not even defined. Oh, it's called coconuts saved. Gotta remember the names of the variables here. Be consistent with the names. Like, it's gotta be the same name that you're referring to. Okay, so issue should be fixed. Let's shake the tree. Let's just save the coconut for later. That's fine. Then we can pick up a rock, throw the rock at the coconut. Okay, so we've survived 2 days. Our hunger level is 1. Oh no, if it's been 2 days, our hunger level should probably be higher than that. Our hunger level should just increase every day. Thirst level. So, anyways, when we threw the rock, now we have 3 rocks. How many times are we getting rid of the rock? So, we pick up a rock, rock's available -1, and we throw the rock at the goat, or we throw the rock at the coconut. We should not worry about getting rid of the rock here. That's the issue. We don't want to get rid of the rock, again, after throwing a rock at a coconut. Yeah, that just doesn't make sense. I want to pick up a rock, and I want to throw the rock at a coconut. Now we have 4 rocks. That makes more sense. 9 coconuts in the tree. One more coconut. So we saved a coconut. We still have a goat. Well, we won't have a goat for long because the next thing I want to do is I want to pick up a rock and I want to throw it right at that goat. The goat's been hit. What do we want to do now? We threw the rock at the goat. I just want to like save the meat. So we saved the meat. We have no goats left. But what if we say keep throwing rocks at the goat? The goat's been hit and I want to save more meat. Well, we have 2 meats saved and negative goats, so we should not be allowed to do that. You know, we could go in and we could say, let's not even allow ourselves to throw a rock at a goat if there's no goats left to throw a rock at. You know? Why would we even be allowed to do that? There's no rocks. There's no goats. So how would we do that? You could put an if statement here on throw rock, at goat. Say, you know what, if this decision 2 is A and goats, is greater than 0, there's more than 0 goats, you can do that. Oh no. This is where you might want to do else if and else to get fancy. So like you could say, you know what? Maybe we just like have them lose a turn. They just skip over all this. They don't even have an option to throw the rock anymore, maybe. They just lose a rock. They try to throw it at the goat that doesn't exist. Or, you could ask them, hey, try it again. Throw the rock at the only thing you can throw the rock at. Or we could just say a message like, sorry, you can't throw the rock at the goat. You threw the rock at the coconut. That's what, I think that's what I'm gonna do. I'm gonna just like go inside here before we even try to throw the rock at the goat. I'm gonna do another if statement. Say if the goats are, 0, for example. Let's say less than or equal to 0. Magically somehow there's negative goats. Then inside this if statement we're gonna say print no more goats. You instead threw a rock at a coconut. But what if there's no more coconuts? Say if coconuts in trees is less than or equal to 0. Actually, let's do it before we mention anything else. Also, say, sorry, no more goats, and no more coconuts. And then else, say else. If there are coconuts in the trees, we want there to be coconuts in the trees for you to be able to say there's no more goats, but there is, you can throw a coconut in this tree still. And then we can say throw a rock at coconut here, taking care of like these very special cases where people try to throw rocks at things that aren't there. This is how it works. No goats. Well, what if there is goats? You want to say else here so that this doesn't happen, regardless of what happens here, this would have ran if we didn't have the else. So wait, before we see if it works, I found something interesting here. What if we flip the logic here and if you run out of, let's say, A is trying to throw a rock at a goat, but let's say you throw a rock and you don't have any more coconuts, we should probably try to throw a rock instead at the goat. And if there's no more goat, you just say, sorry, you don't have anything else to throw at. Like, there's no more, the goats, no more coconuts. You want to do the same thing down here. So let's just do the same thing. If we have coconuts in trees greater than or equal to 0, throw a rock at coconut. Else, you can say, sorry, there's no more coconuts. And if, you know what, we could probably do it like this up here too. If we have no more goats, we said we should just say,
sorry, no more goats. Can't throw a rock at anything. Else, there must be goats otherwise. Then you just have, let's just throw the rock at the goat.
so this could be, you know, this is a logic we could put, you know, similarly up here, we could put the same thing up here. This is just a different way to do it. Flipped between, you know, coconuts and goats. Anyways, we could also put it outside these if statements and, you know, have another, maybe even more elegant way to do it. But for now, let's just see if what we have, this whole thing, let's just see if this works. It looks like we are changing, we need the goats value, so let's make sure we add in goats here.
Lovely. And coconuts and trees. Let's see if that works. If we throw, yeah, we just have to pick up a rock and throw it somewhere.
Let's run this code. Do you want to pick up a rock? Yeah. Throw a rock at goat. Yeah. The goat's been hit. Let's save the meat. Now we have no goats. Let's pick up a rock and try to throw it at a goat again. Sorry, no more goats. You instead threw a rock at a coconut. One more coconut. So it looks like you repeated this. I could probably take out this text, since when you use the throw the rock at the coconut function, it apparently prints that for you anyways. So it looks like we still have 0 goats. We have 1 meat. We have less coconuts. Yeah, we've saved a coconut. It was forced upon us to save a coconut. And we've used 2 of our rocks now. 1 for a coconut, 1 for a goat. Let's pick up another rock. Let's try to throw it at a coconut. Can't throw a rock. Well, that's not true. Looks like the logic is flawed here. Well, if there's no more goats and you have no more rocks. So this should all be in the case. This should be in the case actually that there's no more goats and there's no more coconuts. So this else covers the case where, you know, there's no coconuts. So let's actually indent this to go inside the else. Yeah, let's just see how that works. So let's try to pick up a rock and throw it at a goat and save the meat. Let's pick up a rock. Let's throw it at a goat. Maybe we shouldn't even give that as an option. Like say, hey, don't even allow them to like have throw rock at goats as an option for the question. That's another way to change the logic in the game. So you try that. That might get rid of a lot of unnecessary code that we have up here with all these if statements, if else's. Looks kind of ugly. It's getting kind of messy in here. So let's put this back up here. Do you want to pick up a rock? Pick up a rock. Let's throw the rock at the coconut. You threw a rock at a coconut. You have 1 more coconut and 1 less rock. So saved coconuts 2, goat 0, meat, rocks available 2. Huh. So a rock went into saving meat, 2 rocks went into saving coconuts. Looks like everything's being preserved properly. So yeah, we have 2 coconuts from the trees. 2 coconuts from the trees. Hunger level After 3 days, our hunger level is 1. That doesn't make sense to me. I think we're actually just going to go down here and make sure the hunger level goes up. Save some meat. Let's throw a rock at a coconut. Like, my hunger level is 3. When do I die? These are the dynamics you gotta think about in a game like this. It's getting pretty detailed. You know what? Let's make some rules. Let's say my hunger level reaches 5 and my thirst level reaches 3, I die. Okay, then in that case, we gotta like increase the thirst level every time too. So make sure we increase the thirst level here. Here we go. So when do we use show stats? Is it down here? Yeah, it's right here. So before we show stats, check if dead. That's a good function to check to see if you're dead or not. Then if we define check if dead, you gotta think, okay, so if, oh yeah, we gotta remember global, what are we gonna check? We're gonna check, hunger level and thirst level. Those are the things we're trying to measure here, so global hunger level, global thirst level. If hunger level is greater than, no. Yeah, greater than or equal to 5. So what we gotta do is we gotta say they died and then exit the while loop. So don't enter it again. You're gonna skip this and just say you died. So let's do that. If the hunger level is greater than 5 or
thirst level is greater than or equal to 3, print, sorry, you died. That sucks. Okay.
so yeah, you print sorry you died, and then you can set play game, which should be global in here also. Play game. Set the play game equal to, I don't know, just say n. It could be anything since it's, an else down there. So let's see what happens. Let's try to just get really hungry or get really thirsty. Okay, so
Let's just keep shaking the tree. Open coconut with rock. Sure. Oh no, let's save the coconut for later. So, hunger level, thirst level 2. Oh geez, maybe that was a bad idea to shake the tree. If I shake the tree one more time, I'm dead. I'm gonna try to just like actually play the game. Make it good or something, like try to win. So, okay. A rock. I picked up a rock. Okay. Yeah, let's throw a rock at a coconut. Oh, I died.
so how do I win? I can't win this thing, Because, like, if I throw a rock at a coconut just to save it, we gotta have some logic in here that says I can actually use my coconuts before I die, Interesting. This is an interesting game. So what if we just, let's say we only die if you have no coconuts left, you have no meat left, and your hunger level is greater than 5 or your thirst level is greater than 3, you can satisfy your hunger with, the meat. You can satisfy your thirst with the coconuts. And here, before you die, before you actually say, yeah, we're dead, and here, let's just make another variable that's like, or make another function that just says like replenish use items, and then like if we have items, we'll use them. Use items. And so like if for example if you have saved coconuts, then the number of saved coconuts you have, that's how much less thirsty you're going to be when we use the items. So how would we ensure that our thirst level goes up the same amount that our coconuts, like the same amount of coconuts saved that we have? So like all we would do is we'd say
Thirst level. Oh yeah, by the way, global coconuts saved. Global thirst level. Now the thirst level, you should subtract the amount of coconuts saved. You know? Does that make sense? So like, minus equals coconuts saved.
so what if thirst level, like, what if your thirst level is 2 and you have 5 coconuts saved? Then your thirst level would be -3, but that won't work. You can't do that. So it's got to be a different way to do this. But you know, let's just maybe we just have to get rid of all the coconuts. We just have to use all the coconuts we have, and that's part of the game. You just have to figure out how to like not let your coconuts expire and starve. So after we use all our coconuts, we'll set the thirst level to, let's say, yeah, like if the thirst level is negative, we'll set it back to 0. So
if thirst level is less than 0, we'll just set, oops, we'll just say thirst level equals 0. There we go.
and then we have to make sure that the coconuts, you know, saved coconuts are all utilized. So set that back to 0 too. And it looks like this is good to go. You know, use items is being utilized here. So check if dead happens here. And we should probably notify that, like we'll say, hey, you're about to die. So you have to utilize your items. And if there's no items, we'll say, sorry, you have no items. Yeah. Print utilizing items close to death.
Don't let thirst reach 3. Probably do that on a new line. Don't let thirst reach 3. Don't let hunger reach 5. There we go.
We could probably put these globals at the top, actually. Just for consistency. And then if
coconut saved is less than or equal to 0, and meat, saved meat, oops, saved meat less than or equal to 0, it looks like you ran out of food and water.
And from that, they will probably find out, well, this if statement, we'll skip. We don't have coconut saved. Thirst level will not go lower than 0 if this isn't ran. Coconut saved, if it's, gets to this point, this is already 0, so this won't make a difference. Yeah, this function should do exactly what we expect it to. So let's test it out.
Coconuts and trees. I want to start, like, I just want to, like, pick up a rock, and I want to throw the rock at a coconut. And how hungry am I? 1, there's level 1. I probably, I should probably shake a tree. Shake a tree. You shook a tree, coconut fell on the ground, congrats. Open coconut with a rock. Let's open the coconut with a rock. Hunger level 4. There's level 0. Okay, we need a goat. Like, I have got to pick up a rock. And I've got to throw it at the goat. And I've got to eat that meat right now. Hunger level back to 0. There's level 1. So, I'm kind of getting thirsty. So...
But holy cow, how did we get like 4 for the hunger level? Yeah, that was weird. I think, maybe we shouldn't like manipulate hunger level in one of those other ones. I think that was bad. Bad idea. Well, no, when you're shaking trees, they can get pretty hungry, so maybe that makes sense. But it went from
hunger level being from 1 to 4. Like, how does that happen? Got 3 hungries? How do I get 3 hungries? In just one day.
Looks like it's right here. And also opening the coconut. I don't think hunger level should go up just by opening a coconut. I mean, who knows? You might be really skilled at opening coconuts and it doesn't take a lot of energy. But shaking a tree, climbing a tree, getting a coconut, get pretty hungry from doing that. So let's see what happens. Let's retest this out. Let's go back in. Do you want to pick up a rock? Yeah, let's pick up a rock. Throw a rock at coconut B. We can afford that. So hunger level, thirst level. Uh, you know, 30%, like we're 30% ready to die with our thirst level, like 1 out of 3. So I think I'm gonna shake. No. Yeah, we're gonna have to shake the tree. And then immediately open the coconut. I don't want to like get thirsty. So thirst level 0. Hunger level 3. It could get up to 5 though, so like maybe we should like have some way to eat coconuts to get less hungry. You know? Also, we didn't take care of hunger level here. If we happen to have meat saved meat, no, saved meat, then if saved meat is greater than 0, then the hunger level, you know what? Let's just set it equal to 0. We have to use our saved meat. And then the hunger level, like if the hunger level is less than 0, if it ends up being less than 0, well, that can't happen. We just set it to 0 if we have meat. So it's simple. And then we have to make sure that we have to set saved meat back to 0. Oops. So let's play that again.
Welcome to Virtual Island Survival. Get started? Yeah. You want to pick up a rock? Yeah, I want to pick up a rock. Throw a rock at coconut? Yeah. Pick up a rock. No, shake the tree. Get the... Oh no. We have to open the coconut. So we're not thirsty, now we're hungry. You want to pick up a rock? Yeah. Throw it at the goat. Goat's been hit. Eat the meat. Hunger level 0. There's level 1. Oh no. This is not looking good. Now there's no goats left. We don't have any meat. We've survived 3 days. You know? There's no winning. There's no winning this. What if we could use the, like, What if we could use some of our energy to build a boat with the tree? So we like eat the goat right away, build a boat, and then eat jellyfish. No, don't eat jellyfish. Um, yeah, let's try. Jeez, if I was in this situation, I'd try to get calories from coconuts if I could. So let's just shake the tree. No, let's pick up a rock. Pick up a rock. Throw rock at coconut. See, the hunger level only went to 1. So I can afford to do this 5 times. Like, because the thirst level goes down. Because I'm going to have a bunch of coconuts. When I, almost starve to death. Okay, pick up a rock. Throw a rock at the coconut. Wait a minute. It made me die anyways. I had coconuts though. Oh. So, we should use the items before we do this check here. Yeah. I don't know what I was thinking. We should use the items before we check to see if we're dead. You know? Yeah. So, let's get started. Let's pick up the rock. Let's throw it at a coconut. Pick up a rock. Throw it at the goat. Let's eat the meat. Right away. Let's shake the tree. Let's open coconut with a rock. Shake the tree. No, 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 no. Don't shake the tree anymore. What am I doing? A. Pick up the rock. Throw it at a coconut. Pick up the rock. Throw it at a coconut. Okay. So in the hunger level...
Okay, so like yeah, this worked. So we utilized our items, we were close to death. It forced us to use, you know, our coconuts to get us less thirsty. But now we're like in a conundrum because like it looks like the coconuts are not doing anything for hunger. So maybe your task can be take away some hunger with the coconuts, like take away half, you know, half of a value maybe, or take away one randomly, or every time you have a coconut, take away one hunger and one thirst. So there's an infinite number of possibilities, infinite number of directions you can go with this. This could turn into a huge game that people could end up loving. I have no idea. I probably wouldn't play this all day, but for, someone who's learning to program, I think this is a pretty good thing to be able to build. And if you can build this, if you understand everything here, I have confidence you're going to be able to build much bigger, really cool, complex, amazing things in the future. So, congrats for finishing this entire course, Fundamentals of Programming, Part 1. We're going to move on to more complex topics and get some other fundamentals taken care of before you move on to web development basics and have fun with your game.